Today we are going to be talking about gravity and friction. You can choose to do a split screen and type your notes, or you can use your lab notebook and handwrite your notes. Feel free to press pause whenever you need to catch up on the video. You're in charge of what notes you're writing down. I'm giving you some guidance on what to write down, but more information is probably better. Okay, here we go. Our essential question for the day is, how do forces affect the motion of an object? And what is friction? Friction is a force that opposes motion. So anytime something is moving, there's friction against it, slowing it down. So talking about Newton's first law, how an object in motion stays in motion unless acted upon by an unbalanced force. Whenever something is moving, that unbalanced force to slow down an object is going to be friction. And there are two kinds of friction. We've got static friction and kinetic friction. The word kinetic means moving. So when something is moving, there are types of kinetic friction acting against it. Now if we look over here on the left, we've got static friction. Static friction is the force that opposes motion to keep it from moving. So here you can see the ladder is not moving. And the reason behind that is because the ladder is leaning in such a way that the friction is equal to the downward force. So it's keeping it up. So static friction is where the forces are balanced and the object is not moving. Kinetic friction happens when objects are moving. Now there are three kinds of kinetic friction, or three kinds of moving friction. There's rolling, fluid, and sliding. Rolling friction is anytime there are wheels, so a car moving on your roller blades, your skateboard. When the object is moving forward, there's rolling friction against the direction of the movement. Fluid friction is the same as air resistance in the air. We also call it fluid friction because it applies to objects underwater as well. So when that jet is moving to the right, there's fluid friction or air resistance going to the left. So fluid friction is acting against the object where it's moving. Same thing with the fish. The fish is moving to the right, and there's fluid friction acting to the left against it. Sliding friction is just what it sounds like when an object is sliding against a surface. So what types of friction are there? There's static friction, where the net force of the object is zero. The forces are balanced and the object is not moving. And then we talked about the three kinds of kinetic friction: rolling, fluid, and sliding. So what causes friction? And there's two things that cause friction. There's one aspect is the roughness of the surface, and another object is the weight or the downwards force acting on the object. So talking about the roughness of the surface, if you're looking at the kids on the slip and slide, that's a very smooth surface with a low amount of friction. If those kids were to do the slip and slide on asphalt instead of the slip and slide, it's a much rougher surface with a higher amount of friction. It would hurt. It would not be as fun. A slip and slide is fun when the friction is low. Now, when you're looking about the elephant on the right-hand side, if there was less mass on the elephant acting downwards, it would be easier to slide that elephant into its crate. Now, because it's a big boy elephant, it has greater force downwards, so a greater amount of friction. So what causes friction? The surface of the object causes friction. The amount of friction depends on the roughness of the surface and the amount of force applied. So how do you reduce friction? How do you make things easier to move? So looking at the slip and slide, you can decrease the friction by adding soap. So adding that oil creates that smoothness, makes less friction. For the elephant one, if we had a smaller elephant, a baby elephant, with less applied force, it'd be easier to push and slide that elephant into the crate. So how do you reduce friction? You smooth the surface, or you reduce the force. You reduce that weight. But what is the difference between mass and weight? The mass that we've talked about is a measure of the amount of matter in a given object. So this is measured in grams and kilograms. And then we have the weight. The weight is the measure of the gravitational force exerted on an object. So weight is measured for us in pounds and has to do with the gravitational force. So gravity is a force of attraction between two objects that is due to their masses. Here are the definitions again. So weight depends on gravity. All things that have mass, all matter, experiences gravity. The Earth's mass, therefore its gravitational pull, is larger than every object on Earth. So therefore, we're all being pulled downward because of the Earth, the gravitational force between us and the Earth. The Earth rotates around the sun, is being pulled by the sun because of the mass of the Earth and the sun and the distance between the Earth and the sun. Now, the law of universal gravitation says that the force depends on the product of the masses of the objects and the distance between them. So gravity on Earth, our weight would be different on Earth compared to the moon. So if we multiply the mass of ourselves times the mass of the Earth times the gravity divided by the distance squared, we would get our force due to gravity, which is our weight. Our weight on Earth is different than on the moon because there's less of a gravitational force. There's less gravity on the moon. That has to do with the size of the moon. The moon is much smaller than the Earth. Therefore, there's going to be less of a pull. So that is why our weight is different on the Earth versus the moon, but our mass is the same. The mass does not change. You don't change how much there is of you from the Earth to the moon. Now, all objects fall with the same acceleration near the surface of the Earth. Every object, no matter its size, no matter if it's a tiny ping pong ball or if it's a ginormous bowling ball, all objects fall with an acceleration of 9.8 meters per second squared. All objects are accelerating at that constant rate. So the object falls faster and further each second than it did the second before. The velocity is increasing. So as you can see over time, there is a greater distance because it's accelerating. It's not constant, it's gaining speed as from the higher you drop. But everything accelerates at the same rate, 9.8 meters per second squared. So I want you to think about these questions. How does fluid friction affect an object when it's dropped? How does mass affect how fast an object falls? I want you to think for 30 seconds. All right, let's talk about the first question. How does fluid friction affect an object when it's dropped? Fluid friction opposes motion. So because on Earth we have air, you can even move your hands around and you can feel that fluid friction against your hands. Fluid friction going upwards causes things to fall slower. So when we're talking about that tennis ball and basketball example, if we drop them from the same height, The basketball would hit first because the tennis ball would have more air resistance against it, more fluid friction, so they would not fall at the same time on Earth. If we were to remove all of that air, and if it was in a vacuum, then they would fall at the same rate. So the thing that's affecting objects on Earth, why they fall at different rates, has to do with fluid friction. How does mass affect how fast an object falls? Does not matter the mass, objects will fall at the same rate. The only thing that affects the time it takes for an object to fall to the ground has to do with the fluid friction. All right, those are our notes.